Hello everyone, I am Shubham Garg and welcome back to the lecture series of Java. So in today's lecture we are going to see how to make a program for selection sort. Alright, so selection sort is another sorting technique like bubble sort, and it is a bit better than bubble sort. There are less number of swappings done in the selection sort. Okay, so less swapping than bubble sort. And also it is a quadratic complexity. It has a quadratic complexity that is O n square. Okay, but there are the swappings is less, so in a way it is a bit better than bubble sort. All right, so let us see what selection sort is. Okay, so let's get this array. Okay, we will going to use previous array which we use in the bubble sort. So the array was 5, 25, minus 4, 8, 55 and 2. So this was the array. Okay, and here again we need to mark the starting and ending of the array. So here this was the start and this was the ending, that is the last unsorted element. All right, so here again these positions are 0, 1, 2, 3, 4 and 5. All right, so now what is going to happen here in the selection sort, what we are going to do is we are going to traverse the array from left to right. All right, left to right, and it is going to find the largest element. So it is going to traverse from left to right and it will find the largest element, and then it is going to place the largest element to the end. All right, that is, for example, here 55 is largest, so first this will go to the end. All right, then the remaining elements will be there in the array. In that the largest element will go to the second last position, that is 55 will go to the end first, and from the remaining elements after that 25 will go towards the second last position, and that's how the selection sort is going to work. So there are less number of swappings as compared to bubble sort. So let us see how the selection sort is working. So our array was 5, 25, minus 4, 8, 55 and 2. All right, so first of all here it will start from left to right. Okay, that is I let's say there is a variable I that will be equal to 1. All right, because it is the first traversing, and here for first this is the largest. All right, it is going to get the largest element to the end. So largest at the point, at the moment it is at the position 0. All right, so then it is going to compare the largest with the adjacent element, that it is going to compare 5 with the 25. All right, so here 25 is greater than 5. All right, so therefore 25 becomes the largest. All right, so 25 becomes the largest. Hence for I is equal to 2, next traversing we have array such as 5, 25, minus 4, 8, 55 and 2. All right, now here largest is equal to element on position 1. All right, so now it is going to compare from the adjacent element. So it is going to compare 25 with minus 4. 25 is greater than minus 4, it holds true. All right, then it is going to compare with the next element because it needs to go to the position where it should be at the end of the list. All right, or any element larger than that should be at the end. Okay, so then it is going to compare next thing in the next pass, that is I is equal to 3. It will see 5, 25, minus 4, 8, 55 and 2. All right, so at this point it is going to compare it to 8. still this is 25 is the largest, so I is 3 and largest is still 1, that is largest element, it is still 1. Alright, similarly it is going to compare it with next element, that is 55. So in the next pass what is going to happen is I becomes 4, alright, and here it will see 5, 25, minus 4, 8, 55, 2. So when it is going to compare 25 with 52, what will happen? 25 is less than 55. Alright, so 25 is no longer the largest. Okay, not largest. And the largest element becomes 55. This becomes new largest. Alright. So here largest becomes largest is the fourth element. Alright. So we have now our largest element, that is 55. Now it is going to compare with other elements to see if it is the largest or not. So the final element which is remaining here is 2. So in the next pass, that is I is equal to 5, it is going to be like this: 5, 25, minus 4, 8, 55 and 2. Alright, so it is going to compare it with this. Now 55 is largest, so largest equal to 4, okay, that is the fourth element. Hence swap, and since it is the end, okay, 2 here, okay, just a second, yeah, so 2 here is the end of the array, okay. So now swap 55, okay, and 2. So we need to swap both of these. So after swapping 55, that is the largest, will come to the end. Okay, so this was the first traversing of the whole list. Then since 55 is at the largest position, we will do the same procedure for the other elements. So let me just increase the size here. Okay, yeah. Alright, it is fine now. So now we have swapped 55 and 20 and 2. So our new array becomes 5, 25, minus 48, not minus 48, it is minus 4 and 8. Minus 4, 8, 2, and then it is 55. Alright. So now what's going to happen is it is going to start again, that is I is equal to 1, it will see this 5 is largest at the moment. Alright. So now it is going to compare it with 25. So here 25, after that 25 is going to become the largest. Alright. In I is equal to 2, 25 becomes the largest, and it is going to again compare itself with all the other elements which are there. So it is going to compare it with 4, it will be the largest, then it is going to compare with 8, it is still the largest, and at the end it is going to compare itself with 2, it is again the largest. So since after that it is going to not going to go to 55, because we have already placed the largest element in the end. Alright, so now 25 is going to be swapped with 2. So now swap 25 with 2. Alright, so our new array becomes 5, 2, minus 4, 8, 25 and 55. Now you see the last and second last numbers are sorted. Okay, then again we are going to start from the beginning. Here we will take this as the largest. So now it is going to compare itself with this. So this holds true. Then it is going to compare itself with 4. This again holds true. And then it is going to compare itself with 8. So now 8 is larger than 5. So 8 becomes largest. Okay, that is 8 is the new largest. And we will see there are no more elements left to compare because these two are sorted already. Hence 8 is as the correct position. Okay, then after this again it is going to start assuming 5 as the largest. So now these three elements are sorted. So it will compare 5, this will become largest. It is going to compare it with 2. So 5 is greater than 2. Okay. So then it is still the largest. Then it is going to compare it with -4. That is 5 is greater than -4. So it is the largest. Then it is going to compare it with 8. Alright. Sorry, not 8. This is already sorted. So this fourth is largest. Okay, so I will just erase this. Yeah. So this -4 is less than 5. Okay, so now we are going to swap 5 and -4. All right. So now our array becomes -4, 2, 5, okay, 8, 25 and 55. So now here we can see it is going to assume this as largest and it is going to compare it with the adjacent element. So it is not larger, hence this is the smallest element. So thus we can see our array is in the sorted order. Okay, so this is how we do the sorting using selection sort. All right. So it is, as I said, quadratic complexity. It has quadratic complexity of O(n) square, but it has less number of swappings than bubble sort. Okay. So this is how selection sort works. So we have seen the theory for the selection sort. Okay, and in the next video we are going to see how to write the program for selection sort. So this is all for this video. See you guys in the next video.